Hey folks, welcome to my channel Number Pen. So today we have an interesting problem on our screen here. So this is one such problem that helps us understand the real world application of the concept of limits in differential calculus. So let's take a few seconds to read through the problem. An important problem in fishery science is to estimate the number of fish presently spawning in streams and use this information to predict the number of mature fish or recruits that will return to the rivers during the reproductive period. If S is the number of spawners and R the number of recruits, the Beaverton Holt spawner recruit function is R of S, which is the number of recruits, is equal to S divided by alpha S plus beta, where alpha and beta are positive constants. Show that this function predicts approximately constant recruitment when the number of spawners is sufficiently large. So I want to draw your attention to the last line in this particular problem. So basically, what we've been asked to show is as the number of spawners, which is S in this equation, becomes sufficiently large. And what do we mean by sufficiently large is S tending to infinity, right? S is the number of spawners. And we've been asked to show the function, which is R of S, which is nothing but the number of recruits that returns to the rivers, becomes a constant, right? Or it's approximately constant. So indirectly, what we'll have to figure out is what is the limit of this function R of S when S tends to infinity, and we are done with that, right? So seems like a very simple application of limits once we understand what we have to do to arrive at the final answer, right? So I'm just going to copy this equation. Let me write limit so when the spawners is sufficiently large, we have S tending to infinity, right? And I'm just going to copy this function as it is. So we know how to solve this problem. It's not a complicated problem that we have once we know what we have to do after interpreting the problem and what we've been asked to find in the problem. So I'm going to divide this by S, right? We know how to solve the limits for a function which is of the type P by Q. And here it is indeed of the type P by Q. So when I do this division, all that I get is alpha S by S plus I'm going to write this as beta by S, right? And as S tends to infinity, we know that this S and this S will cancel out, and we are left with 1 divided by alpha because the S and S is cancelled out, and when I have beta divided by S, as S tends to infinity, you've got beta, which is a positive constant. So a positive constant divided by infinity is nothing but you have 0. And this is the final answer for this question. We have 1 by alpha, which is indeed a constant because alpha is a constant, and therefore 1 by alpha will also be a constant, and therefore the number of recruits as S becomes sufficiently large, which is the number of spawners becomes sufficiently large, will tend to take the constant 1 by alpha. And that's the final answer for this problem. Thank you. Please do subscribe to my channel and support.